Hello everyone and happy Monday. We're going to start our very first lecture session, pardon that marker, today with polynomials. And then this will correspond to chapter 12 in your study plan. Okay, so again, the handouts are listed in Blackboard under the handouts tab, of course, and they'll be labeled based on which topic that we're going to be talking about. Let me try this marker, see if it's a little bit better. So this isn't going to be really a formal lecture where I'm introducing a lot of new material. I'm basically going to be walking through this handout, and then if you have any questions, feel free to email me, text me, anything of that nature, and we can go through it, or we can set up a Zoom session. So we're going to start with some basic rules. The first one is the product rule. So that's a to the m times a to the n. And this particular instance, a is your base in each case, and then m and n are your exponents. So if you're multiplying two terms together with the same base, you're going to add your exponents. So as just a brief example, if we had x squared times x to the fourth, that is x to the sixth. Another way of looking at this is x squared, that means you're multiplying x together 2 times, and then we've got times x to the fourth, that's another 4 x's, so that's a total of x to the sixth. The 6 x's multiplied together. Okay, so this one's the product rule. And then next we're going to look at quotient rule. So again, we have two terms. They have to have the same base before this rule applies. And this time you're dividing them together. So we're going to take the exponent in the numerator minus the exponent in the denominator. So again, it's just kind of a quick example. We'll go ahead and do x to the second divided by x to the fourth. And then I'm also going to do x to the fourth divided by x to the second, okay? So x to the second over x to the fourth, again, we're going to keep the base x, and then we're going to take 2 minus 4. So be really careful with your signs here. So 2 minus 4 is negative 2. Whereas this instance, we have x to the fourth divided by x squared. So this time we're going to take 4 minus 2, so it's going to be positive 2. And one more rule that I don't have listed on here, but it actually ties in perfectly, is if you have x or a to the negative m, this would equal 1 over a to the positive n. So you're basically just flipping it. This a would assume to be in the numerator since we don't see that little fraction bar at all. And so I'm going to put it in the denominator, and then we're just going to leave a 1 as a placeholder. Or similarly, if we have a term with a negative exponent in the denominator, now I'm going to put it in the numerator and multiply by whatever is there already. In this case, it's just a 1, and then change the sign. So going back to this one, after we've looked at that rule, to rewrite that in terms of positive exponents, I'm going to put the x in the denominator, change the sign, and then we'll just put a 1 as a placeholder. So again, another way of looking at that is think of it like a teeter-totter. Whichever side is heavier, that's the side that it's going to go to. So we have the bigger number in the denominator, so it's going to end up in the denominator with a positive exponent. Similarly here, we have the bigger number in the numerator, so it's going to end in the numerator. And then one more way of looking at division. So again, if we had x to the fourth divided by x squared, we can think of it as canceling like terms between the numerator and denominator. And then we're left with x times x, which is x squared in the numerator. And then it would be the reverse. If you had the bigger number in the denominator, you'd have your 4 x's in the bottom, 2 x's in the top. So you would end up with your value in the denominator. Okay, so there's one more rule that I have listed here, and that is the 0 exponent rule. So anything raised to the 0th power is 1. So I'm going to do a few examples with this. So if we had x to the 0th, that would be 1. if I have negative x to the 0th power, now you'll notice the 0 is attached directly to the parentheses. So we're basically replacing everything inside the parentheses with 1. Whereas in this previous example, the 0 was attached directly to the x, so that is the only term that you're replacing with 1. And so if I had it negative x to the 0th now without the parentheses, again, the 0 comes directly after the x, so this is 1, and then we're going to multiply by the negative out front. So it actually changes the sign, and that becomes negative 1. Okay? All right, so that's kind of the little introductory material, just a quick recap for it. Hopefully it'll kind of come back to you as we start going through this material. And then now we're going to start working on the problems. So the very first section involves adding and subtracting polynomials. So essentially what we want to do is we want to add like terms. So a like term is anything that has the same group of variables with the same exponents. So xy. If we were adding like terms, I would need something else that has an x and a y. Order actually doesn't matter. So as long as both of the terms have an x, both of the terms have a y, they would be considered like terms, and you could add them together. X squared has to be added with anything with x squared. X, of course, like terms would be x. So just keep that in mind. So let's go ahead and look at the first grouping. We've got the 2x squared plus 5x minus 3 added to 5x squared minus 2x plus 7. So these are both examples of polynomials. Polynomial means many terms, and polynomials have to have your variable raised to either a positive exponent, so like x squared, x to the 5th, but those exponents have to be whole numbers. So you can't have x to the 2/3 or x to the negative 5. And then similarly a constant, that would be akin to like 3x to the 0th power. In other words, that variable isn't there. So it's like 3 times 1. So keep that in mind as well. So either a constant, which is the x to the 0th term, or they have to have positive whole numbers to be classified as a polynomial. Okay, so what we're going to do here, honestly, I like to get rid of parentheses first and foremost. If you can simplify in parentheses, do that. And we can't do anything. So to get rid of the parentheses, you would distribute anything that's out front. In each case, we're just assumed to have a positive 1 out front, so I can really just drop the parentheses. I don't even need to write them. And now, there's a couple different ways you can add these. You could either line up all your x squared terms, x terms, and constants in columns. You can rearrange them. Addition is commutative, so we can change the order. So I could do the 2x squared and the 5x squared, the 5x, the negative 2x, and group them together like that. Another thing I do is I'll just put like 1 line under my x squared term, 2 under the x's, and 3 under your constants. Obviously, you don't need to do that if you can see it right away. You don't even have to identify them. So make sure you include the sign that comes directly before that term as well. So we've got positive 2x squared plus a 5x squared. That is 7x squared. Positive 5x, negative 2x. That's positive 3x. And the negative 3 plus 7 is positive 4. Okay? At this point, we're done. We've simplified as far as we can go. This is just an expression because I don't see the equal sign, so I can't actually solve for x. Similarly, I like to write them in descending powers of the variables. So we start with the x squared term. This would be considered x to the 1st because you don't actually see an exponent, so we just assume it is 1. And then this would be the x to 0th term because it's the constant. So again, we don't need to actually write those, but just so you're aware of that's how we write them in descending order. You don't have to, that tends just to be the tradition, if you want to call it that. Okay, so that is the very first problem. And then if we move on to the second one, you'll notice there are no parentheses here, so we don't have to worry about distributing anything. Okay, so again, as I look at this, the only variable I see is y. I'm going to start with the highest power in the variable, and as I look through that, it appears to be 5. So I've got negative 7y to the 5th, negative y to the 5th. That's negative 8y to the 5th. And if you want to, you can cross them off after you've combined them. And then we'll move on to y to the 4th terms. And you'll notice each time I add, I'm only adding or subtracting the coefficients. I'm not dealing or doing anything with the variable term itself. So we're just saying I basically had negative 7 of these terms, negative 1, that's a total of negative 8. And then as I move on to the y to the 4th, I have negative 8 plus 2, that's negative 6, and again, y to the 4th. And then I've just got one y cubed term, so I'll just write it as is, and then minus the 9y. So that will be my final answer. Okay. All right, we have one more in this group, and that involves 4 different sets of parentheses. So instead of rewriting it exactly the way it is, I'm going to get rid of the parentheses first and foremost. So if there's a number out front, I'm going to distribute it. In other words, multiply that value by every term in the parentheses after it. So in that second grouping, you'll notice we have the negative out front, so you can either think of it as 2 ways. You're taking a negative 1 and then multiplying each term in parentheses by that negative 1, or we can think of the negative as an opposite. So in other words, you're changing the sign of everything in parentheses after that value. Okay, so that first group of parentheses, there's nothing out front, so I'm just going to literally drop the parentheses. And then we have a minus sign. So that negative, again, I'm changing the sign of every term after it. So that negative 9x becomes positive 9x. And then positive 8x cubed y squared. And then negative 2xy to the 5th. And then similarly for that third grouping, I'm going to change the sign. So negative 3xy to the 5th, negative x squared, positive 18x. And then lastly, we just have the plus, or you can think of it as plus 1 out front. So it's if you multiply anything by 1, it doesn't change its value. So we're going to leave those terms exactly the way they are. Plus 4x squared y cubed minus 11x. Okay, so this has a lot more going on. Got a lot more terms, so honestly, just write it in whatever order you want to, since I have multiple variables in each case. So I'm going to start now with the x cubed y squared. So I've got 5, I've got an 8, and I think that's it. So 5 plus 8 is 13, and again, do not change the order. Now keep in mind that if the term had y squared x cubed, think of that as a like term, because they both have an x cubed, they both have a y squared. So the order of those variables doesn't matter. Okay, then I'll just go on to the next one. I've got the negative 3xy to the 5th. I've got negative 2xy to the 5th. My board is not behaving. And then I've got a negative 3xy to the 5th. So I'm just going to go left to right. Negative 3, negative 2 is negative 5, plus another negative 3 is negative 8. So just remember, if you're doing this by hand without a calculator, if your terms have the same sign, so they're either both positive, both negative, think sum. So you're just going to add them together, and then your final answer will have the same sign as your individual values. So in this case, we had all negative numbers. I just added them together, and then your final answer was negative. If they have different signs, think different. So you're actually going to do a subtraction problem, and then your bigger number would have the same sign as the bigger term. So if you have 2, negative 3, take the difference of, so I always take the bigger number minus the smaller, so 3 minus 2 is 1, but the bigger number is negative. And then similarly, if you had 3 minus 2, obviously, again, do the subtraction, the bigger number is positive, so your answer will be positive. Just a little random side note if you're doing this by hand. Okay, so back to the problem. I combined all of those, and then we're going to move on. The x squared, I've got 12x squared minus 1x squared. So that is positive 11x squared. Again, that's an example where they have different signs, so subtraction. And then we've got 9x, 18x, negative 11x. So 9 plus 18 is 27, and then 27 minus 11 is 16, and that's positive. Okay, and then lastly, we just have the plus 4x squared y cubed. So this will be our final answer. And that is it for those 3 addition subtraction problems. So now we're going to move on to multiplying polynomials. So essentially we're going to use the FOIL method. That's if you have, honestly it doesn't have to be binomials, which is 2 terms, that's the most common, but it could have 3 terms in one, 2 terms in another set of parentheses. So if you're doing FOIL, we're going to multiply the first terms, outer, inner, and last. So we'll go ahead and run through a few examples here. Okay, so this one's actually an example where we have 4 terms in the first grouping, and then 2 terms, so this is just a polynomial, and then 2 terms is a binomial, 3 would be a trinomial. Anything above that would be classified as polynomial, but you'll talk more in depth in your college algebra class. Okay, so a couple ways we could do this. Sometimes you'll see people line it up again, just like we would do multiplication for longer numbers, 2 3-digit numbers. So if you're comfortable with doing that, you've done it before, go ahead and continue doing that. I'm going to use, again, I don't really know that it's called foiling, but just kind of a general method where I'll start with the first term in the first grouping and multiply by each term in the second grouping, and then move on, multiply by each term, and then move on. So essentially you're taking every term in the first polynomial, multiplying by every term in the second polynomial, and then we always end by adding our like terms. So with multiplication, we're going to go back to that original set of rules that I showed you. So if we're taking x cubed and x squared, they both have the same base, x, so we would be adding our exponents. So let's go ahead and do that. We're taking 3x cubed times 4x squared. So 3 times 4 is 12. X cubed times x squared is x to the 5th. So when you add or subtract polynomial terms, do not change the variable. It'll stay the original variable, like x cubed or x squared. When you're multiplying, it's going to change it. And then we'll keep going on. 3x cubed times 3 is 9x cubed. And then we'll move on to the next term. So including that sign, negative 4x squared times 4x squared, that's negative 16. X squared times x squared, when I add the exponents together, we get x to the 4th. And then times the 3 is negative 12x squared. And then we'll move on to the third term, which is positive 2x. So 2x times 4x squared is positive 8x cubed. And then times the 3, we get positive 6x. And then lastly, we'll move on to the constant, negative 7. So that'll give us negative 28x squared, and then negative 21. And at this point, we'll go ahead and combine our like terms. So this is what we call a 5th degree polynomial, because the highest degree or the highest exponent is 5. So we'll start with that term, and I just see one of them. And then again, we'll work our way down to the x to the 4th, 3rd, 2nd, 1st, and then the constant. So just 1x to the 4th, and then 9x cubed plus 8x cubed is 17x cubed. And then negative 12x squared, negative 20x squared is negative 40x squared. And then plus 6x minus 21. So that will be your final answer. So we actually have 6 terms. Okay, so after that, the next one will be much simpler. This is where we can employ the FOIL method because I have 2 binomials, so 2 terms, multiplied together. So first, that would be the first term in my first polynomial times the first term in my second polynomial. So that's going to give me 10, and then x times x. Think of that as x to the first times x to the first. So when we add the exponents, we get x squared. Outer, that's the ones on the far edges. So that's 2x times -4 is -8x. And then for your inner, that's the ones on the 2 inside parentheses. So +3 times 5x is +15x. And then the last terms would be the second term in each polynomial. So +3 times -4 is -12. You'll notice I can combine those 2 middle terms because they both have an x. So the final answer will be 10x squared plus 7x when I add these 2 together, and then -12. Okay. Another little water break, and then we'll move on to the last one before we get into the special products. Okay, so this one only has a monomial, so just a single term out in front of your parentheses. And I threw in a fraction for fun. So what we're going to do in this particular instance is distribute. So I'm going to take this term outside the parentheses and multiply by every term inside the parentheses. Again, the same rules apply. If you're multiplying 2 terms the same base, you'll add the exponents. So -2 times that would be assumed to be 1, and then x to the 4th times x cubed is x to the 7th. -2 times 6 is -12, and then that'll be x to the 6th. And then if we're multiplying by the fraction, we can write that over 1 to make it a fraction, so that's true for any whole number. And then we're essentially multiplying across the top, so -6 across the bottom. Honestly, I tend to like to simplify before I do anything, so this 2 could have canceled with this 4 in the denominator. But if you don't want to do that first, just make sure you simplify at the end. So both 6 and 4 share a common factor of 2, so we're going to reduce that to 3/2. And then x to the 4th times x is x to the 5th. And lastly, -2 times -11 is +22, and then we'll just tack on the x to the 4th at the end. Again, you could think of this as x to the 0th, so 4 plus 0 is still just 4. And that is our final answer. So hopefully it's coming back to you a little bit with adding, subtracting, multiplying polynomials. The next group looks at a few special products. I don't really recommend memorizing these. Instead, just think of if you see x plus y squared, or similarly x minus y squared, or some higher degree like cubed or 4th power, you'll notice that 2 is attached to the parentheses. That means take everything inside of the parentheses, multiply it by itself 2 times, and then you would FOIL, and then you could combine your like terms. So those are what we call perfect square trinomials, or the square of a binomial, depending on which side you're starting, the left side or the right side. Another one that is important is if you see x plus y times x minus y. So in other words, the same terms, but one's positive, one's negative. So those middle terms are going to cancel. So you're basically just squaring the first term, squaring the second term, and then it's negative. So starting on this side, we refer to this as a difference of 2 squares. So the first term is squared, second term is squared, and then it's difference because it's subtraction. Okay, so we'll just go ahead and run through those. Like I said, I'm not going to apply it to the formula. I wouldn't necessarily recommend memorizing them, but they're there for you if you wanted to. So 3x plus 1 squared, if we applied it to that formula, we're taking the first term and squaring it. So 3x times 3x is 9x squared. And then you'll notice it says plus 2 times xy. So 2 times this term and then times this term. So that becomes 6x. And then the last term squared. So that's if you kind of apply it to that formula where it says x plus y squared. X represents the first grouping. So this would be like your x. Y would represent the second grouping, and then you're just plugging in those values into the formula. Like I said, I don't necessarily recommend that. So I'm going to rewrite that as 3x plus 1 times 3x plus 1. And then if we FOIL it, my first terms, 3x times 3x, that's 9x squared. My outer terms, 3x times 1. My inner terms, same thing. That's why we have the 2 times that product. And then my last terms. And then when I combine the middle terms, we get 9x squared plus 6x plus 1. Okay, so the second example is very similar, except you have that 3t out front. So again, we'll have the 3t, and then we have 2m minus 5n. That value is squared, which means I'm multiplying it by itself 2 times. So a couple ways you could do this. You could distribute the 3t first and get another binomial, in other words 2 terms, and then FOIL with the last term. What I recommend is start by FOILing these two and keeping the 3t out front and then distributing that at the very end. That's my recommendation, but again, you can do whatever method you want, provided it's a valid method, of course. So 2m times 2m, that's 4m squared. Don't forget to square that. And then I'm going to do this a little bit. I'm going to cheat a little bit. So 2m times negative 5n, that's negative 10mn. The order doesn't matter. You can write it mn. I'm kind of OCD, so I like it alphabetical order. But if you prefer nm, that's fine as well. So this is also negative 10, either mn or nm. So when you combine those, negative 10, you get negative 20 mn. Okay? And then lastly, negative 5n times negative 5n becomes positive 25n squared. You'll notice I kept them in a set of parentheses. That way I make sure when I distribute the 3t, I do so to all 3 of those terms. So now 3 times 4 is 12. And then again, if you want it in alphabetical order, m squared t. If you prefer the t front, that's fine as well. And then we've got negative 60 nt. And then 3 times 25 is positive 75. And n squared t. So this will be your final, we call it the expanded form because we do not see any parentheses. Also, we've combined all of our like terms. So this would be, the original one is the factored form where you see the parentheses and like terms are grouped so that 2m minus 5n is just squared as opposed to writing it out 2 times. And then this would be more the expanded form. Okay, and then the last one, that's an example of the difference of 2 squares. So same terms, both have a 4a, both have a 3. The only difference is the sign. One's positive, one's negative. So 4a times 4a is 16a squared. My outer terms, 4a times negative 3 would be negative 12a. My inner terms are now positive 12a. And then my last terms, 3 times negative 3, negative 9. So you'll notice these 2 terms are what we call additive inverses. Same exact value, different signs. So when you add them together, they just wipe out. It's just 0. So we're left with 16a squared, which is my first perfect square, and then minus 9, which is my second perfect square. Okay? So we're getting there. We just have one more grouping. We're looking at division, but just by monomials. You look at binomials and higher order polynomials once you get into college algebra. So to start, I have a little formula there for you. It's kind of the reverse of adding two fractions together. I know if I add two fractions together, I need a common denominator, and then I literally follow the operation in the numerators. So a plus b, and then I would put it all over c. So now we can flip that. I'm essentially starting on this side, and then I want to write it as individual fractions. So I take the first term, put it over to the denominator. Then I have my sign to the plus, and then I take the second term in my numerator, put it over the denominator, and then you would continue that pattern for as many terms as you have in the numerator. So that's essentially what's going to happen in the first one that we see, that first quotient. So instead of rewriting it again, I'm just going to split it up. I'm going to take the first term in the numerator over the denominator. And then we've got the minus sign. Second term over the denominator, and then I have a plus sign. Third term, and then minus, and then the fourth term. Okay, and then we're going to treat each of these individually. So again, those rules are back at the very top of the first page of this handout. And so again, do the division with the numbers. 4 divided by 2 is just 2. X cubed divided by x. So we're taking the base x and then 3 minus 1. So that's 2. So I'm essentially taking out an x each time. And then minus 2 divided by 2 is just 1, so I don't have to write that coefficient. And then x squared divided by x. I'm taking 2 minus 1. That's just x. Plus 6 divided by 2 is 3. And now these x's cancel, or you can think of it as x to the 1 minus 1. That's just x to the 0. We know that's just 1. So 3 times 1 is still just 3. And then this one, there's nothing I can do. I can't cancel that x. I'm going to leave it down in the denominator. And similarly, there's nothing in common between the 9 and the 2 that I can cancel out. So we'll just rewrite it. And that will be your final answer. Okay, and then our very last problem, this time it's not written as a fraction, but remember division means the same thing as that little fraction bar. So I'll write it in that format first. So the very first polynomial, give me one moment here. And then divide, I'm going to write it as the fraction bar instead. And then we've got 5m squared n. So when I do that division now, I'm going to again split it up. So I'll take, and instead of splitting it up again, I'm just going to do each step at a time. So negative 10 divided by 5 is negative 2. M to the 4th divided by m squared. You'll notice at this point I have to only group like terms. So m to the 4th, m squared, they have the same base m, so they can be grouped together. And then n squared and n have the same base n, so they can be grouped together. So m to the 4th divided by m squared is m to the 4 minus 2. And then n to the 2 minus 1. And then go on. Plus 5 divided by 5, that's just plus 1. M cubed divided by m squared is just m. N squared divided by n is n. Both of those are to the first power, so we don't need to write that exponent 1. And then lastly, 6 over 5, that's just a fraction in simplified form. The m squareds will cancel, so I will not have an m term. And then n to the 4th divided by n is n cubed. There are no like terms, so at this point we are done. We are simplified. So that is it for adding, subtracting, multiplying, and dividing polynomials. So again, I would strongly encourage you at this point to be working in your study plan under Chapter 12. So if you open up that study plan, click on Chapter 12, It should break it down into sections. Work on the problems in the sections with the little push pins. And again, if you have questions, you can click on the Ask My Instructor. That'll send it to me as an email. You can just send me a straight up email or a text message if you wanted to just have me look at a question, if you wanted to like take a picture of your work and send it to me, or if you actually want to set up a Zoom session, or I will be on campus today from about 3:30 to 7, give or take. I'll head in after our live Zoom session. So I will see you all later. Bye.